Area of a triangle is generally found with the formula area equals to 1/2 base times height. But sometimes it's unclear to us what the base and the height of a triangle are. And when it's unclear what the base and the height of the triangle are, then we don't have anything to plug into the formula. So we're going to talk about a way that we can find the area of any triangle using a different formula. First, what I'm going to do is I'm going to drop in an altitude to represent the height of this triangle. And I'm going to label it H for height. Across from angle B is side B of the triangle. And across from angle A is side A of the triangle. In order to find the height, if we focus on angle C, the height is opposite. And in this right triangle over here, we have the hypotenuse. So we can find the height using sine of angle C, which is opposite over hypotenuse. From here, if I cross multiply, I have that the height is equal to A times sine of C. Replacing the height in our original formula with A sine C, what we have for our area of the triangle formula now is area equals to 1/2 AB sine of angle C. And that's our area of a triangle with trig formula. Now, the useful thing about this formula is that it can be used on any kind of triangle, regardless of what kind of triangle it is, as long as you have two sides next to each other and the angle in between. AB just represents any two sides that are next to each other. You can think of this kind of as SAS. As long as you have two sides, any two sides, no matter what they're labeled, and the angle in between, you can use this formula. Let's see how this formula is used in some questions. In question number 1, we're going to find the area of triangle ABC if side A is 6, side B is 7, and sine of angle C is 1/3. I'm going to draw triangle ABC for number 1, and I don't know it's a right triangle or anything like that. It's just some random kind of triangle here. Side A across from angle A is 6, side B across from angle B is 7, and sine of angle C is 1/3. Careful, that's not angle C, that is sine of angle C. So what we have are two sides next to each other of the triangle and sine of the angle in between, because C is in between the two sides. So using our new area of a triangle formula, 1/2 AB sine of angle C, we have 1/2. The two sides next to each other are 6 and 7, and sine of angle C is 1/3. I'm going to take a second and plug this into my calculator. 1/2 times 6 times 7 times 1/3. And we get that the area is 7 units squared. Moving on to number 2, we're finding the area of a triangle ABC, and we're told that side A is 12, side C is 9, and angle B is 150 degrees. Once again, we have two sides and the angle in between. So we can use our formula 1/2 AB sine of angle C. The two sides next to each other are 9 and 12, and then we need the sine of the angle in between, which is 150 degrees. I'm going to type this into my calculator. Let me type in 1/2 times 9 times 12 times sine of the 150-degree angle. And we get that the area here is 27 units squared. Moving on to number 3, we're finding the area of triangle ABC. If B is 12, C is 14, and the sine of angle A is 3/4. So once again, two sides next to each other, and the sine of the angle in between. So area is 1/2 AB sine of angle C. The two sides next to each other are 14 and 12. And the sine of the angle in between is 3/4. Once again, I'm going to go head on over to my calculator and I'm going to type in 1/2 times 14 times 12 times 3/4. And I got that the area is equal to 63 units squared. Moving on to our next example, we have triangle ABC. And side A is radical 3, side B is 8, and angle C is 60 degrees. So once again, we have two sides with the angle in between. So area is 1/2 AB sine of angle C. So the two sides next to each other are 8 and radical 3. And then the sine of the 60-degree angle that's in between. Plugging into the calculator, that's 1/2 times 8 times radical 3 and I got that the area is equal to 6 units squared. Moving on to number 5, we have an isosceles triangle, so that has two equal sides, with legs measuring 10 inches each and a vertex angle of 30 degrees. Remember that angles opposite from congruent sides in a triangle are congruent. So that means that these two angles are congruent because they're across from congruent sides. So I'm going to see what those angles are. 180, the total of all angles in a triangle, minus 30 is 150, divided by 2 is 75. So I got that each of these is 75. In fact, I don't even need that because we're finding the area. And if we're finding the area, all we need is two sides next to each other with the angle in between, which we actually had from the beginning. So let's do that here. Area equals to 1/2 AB sine of angle C. Area equals to 1/2 10 10 sine of the 30-degree angle. I'm going to type this into the calculator. 1/2 10 10 sine of the 30-degree angle. And we have that the area is equal to 25 units squared. Moving along to the next one, we're going to find the exact value of the area of an equilateral triangle if the measure of one of its sides is 4. So an equilateral triangle has 3 equal sides, so all the sides are then 4. And if we drop an altitude, since it's an equilateral triangle, all the angles are the same. And since it's equilateral, the altitude actually does bisect the angle. Once again, that's only since we have an equilateral triangle. So what we have here are two 30, 60, 90 triangles. And each of these will be 2, once again, because it's an equilateral triangle. So what we need is AB sine of angle C. So let's check it out here. We have two sides next to each other because any two sides next to each other are 4. So I'm going to put that here. 1/2 AB sine of angle C. And let's plug in so far. So any two sides next to each other are 4. because all the sides in this equilateral triangle are 4. And let's take a look at what the sine of the angle in between them is. So the angle in between the two 4s here would be 60. If I use these two sides, which are 4 as well, the angle in between will be 60. And if I use these two sides, the angle in between will be 60. So regardless, the angle in between, whichever two sides I choose, is going to be the 60-degree angle. So sine is opposite over hypotenuse. I already know the hypotenuse is 4, but I don't know the opposite side. But I can use the ratio of the 30, 60, 90 triangles to figure it out, because I already know that the smallest side opposite from the smallest angle is 2. So to get from the smallest side to the middle biggest side, all I have to do is multiply by radical 3, which would be 2 radical 3. So over here, this is 2 radical 3, the opposite side, and sine is opposite over hypotenuse. So sine would be 2 radical 3, let me write that here, over 4, which is the hypotenuse. But 2 over 4 reduces to 1/2. So I'm just going to write that as radical 3 over 2. You can pretend there's an invisible 1 here. You can put it there if you want. So that way you can see the 1/2. But you don't need to put the invisible 1 there. This is good enough. 4 times 4 is 16. Half of 16 is 8. If I multiply 8 by radical 3 over 2, what I have is 8 radical 3 over 2. 8 divides by 2 evenly. What we have is 4 radical 3. And I'm going to write here units squared. That is the exact value of the area of this equilateral triangle. Moving on to the next example over here. Oh, did I skip one? Yes, I did. I skipped one. Moving on to the next example over here, we have a parallelogram whose area is 20. And it tells us that the sides of the parallelogram are 8 and 5. And that means that this side is 8 and this side is 5 because opposite sides of a parallelogram are congruent. We can put a diagonal in, and now we have two triangles. And since these are two exactly the same triangles, since opposite angles of a parallelogram are also congruent, they're exactly the same triangles, the area of each triangle would be half of the 20, which is 10. So if I take my formula for area of a triangle with trig, I know that each triangle has an area of 10. I know that the two sides next to each other are 8 and 5, but I don't know what angle C is. 8 times 5 is 40. Half of 40 is 20. So we have 10 equals to 20 sine of angle C. If I divide both sides by 20, 10 divided by 20 is 1/2. And now, if I want to figure out what angle C is, in my calculator, I could do inverse sine of 1/2, and it will give me the angle C that made the ratio, which is 30 degrees. So the angle that's in between the 8 and the 5 sides in each triangle is a 30-degree angle. And that means these angles need to be 150 because remember, consecutive angles in a parallelogram are supplementary to each other. One more over here. Actually, I think I have two more for this video on area of a triangle at trig. So we have an equilateral triangle, and the area is 72 radical 3. So I'm going to write my formula. Area equals to 1/2 AB sine of angle C. The area is 72 radical 3. And we're finding the measurement of its side. So any two sides next to each other on an equilateral triangle will be equal because all the sides are the same. So if I call them all x, if I take any two sides next to each other, that would just be x times x, or x squared. So I have 72 radical 3 equals to 1/2 x squared sine of angle C. If I multiply by 2 on both sides to get rid of the 1/2, 72 times 2 is 144. So I have 144 radical 3 equals to x squared sine of c. Now, this is an equilateral triangle, so the angle in between the two equal sides will always be 60 degrees. So I'm going to replace that with sine of 60. So now I can divide both sides by sine of 60 so that I can get the term with the x by itself. I'm going to put that into my calculator. And that gives me a whole number that worked out very nicely of 288. And now I just need to take the square root of both sides. So I have that x is equal to radical 288. That does not reduce nicely. That is not a perfect square. So we're just going to have to simplify the radical. So 288 divided by x squared into my y equals. I'm going to hit second, table of values, and I'm going to look for where I see the whole numbers on my calculator. The last time you see whole numbers is simplest radical form, and I see that that is 12 radical 2. So 12 radical 2 is the length of each side of this equilateral triangle in simplest radical form. I have one more example for this video. It is a little bit of a tricky one. It's the second one over here. What we're going to do is we are going to find the area of this regular hexagon. So a regular hexagon means that all 6 of its sides are equal, and that also means all 6 of its angles are equal. So if this side over here is 9, this side over here is 9 as well. And let's see if we can actually find the angle in between, because we know that to find what each angle of a hexagon is, we should use our formula n minus 2 times 180. That gives us the sum of all the angles. And then if we divide by the number of angles that there are, that would give us each individual angle. So I'm going to plug in 6 for n because there are 6 sides of this hexagon. That is 4 times 180 divided by 6, and that is 120. So each angle of this regular hexagon is 120. And if these are 9, this is also 9, this is also 9, this is also 9, and this is also 9 because all 6 sides are equal. So I already can find the area of the 2 triangles on the ends here because I have 2 sides and the angle in between. So each of those triangles is 1/2 9, 9 sine of 120. I'm going to stick that into my calculator. 1/2 9, 9 sine of 120. And I'm going to multiply that by 2 because there are 2 of those triangles. I'm going to also multiply it by 2 in my calculator. And I'm just going to round to the nearest whole number for now. So I got that's about 70. Now I want to find the areas of the 2 inner triangles. What I'm going to do is I'm actually going to use the Pythagorean theorem since they're right triangles. So we know that the hypotenuse is 18 and one of the sides is 9. So that's 9 squared plus b squared is equal to 18 squared. So we have 81 plus b squared is equal to 18 squared is 324. Let me subtract 81. And we have b squared is equal to 243. I don't believe that that works out evenly. It does not. So we can simplify the radical 243. Feel free to use your calculator to do so. And in simplest radical form, that would be 9 radical 3. B is equal to 9 radical 3. So here's 9 radical 3, and here's 9 radical 3. So now we can find the area of these triangles because we have the base and the height. So area is 1/2 base times height. The base is 9. The height is 9 radical 3. So we have half of 81 radical 3. And half of 81 is 40.5. So I have 40.5 radical 3. But the thing is, there's 2 of these triangles. So I'm going to multiply what I have by 2. And I have 81 radical 3. So this is approximately the 70 from before plus 81 radical 3. So if I type it into my calculator, 70 plus 81 radical 3, let's say I'm going to be rounding to the nearest whole number here. The area would be approximately 210 units squared.